My name is Lee Jones, and I'm your resident soil scientist for Area 2 for USDA NRCS. A bunch of fancy rambling I do to make myself sound real important. In truth, I get paid to dig holes and run my mouth. As long as I'm good at one of them two things, I think they'll keep me around. And I'll be the one presenting your 2025 Central Envirothon Soils Training. Now, with the soils pit in particular, you're going to have two tests. One of them will be a hands-on test where we'll go down to the soil pit and we'll do some physical analysis, which I'll talk about through the presentation. The other, I don't know where they get it from. I'm not a part of that process. So I can't talk about what's on the other test, but what I'm going to get you through today, you're going to have enough knowledge to be able to pass both of those tests with flying colors. All right, Russell, hit me. All right, so start out with our quick overview. We're going to go over the importance of soil because this will be on the written test. Soil formation and soil properties, and our hands-on soil coloring and texturing. That last part's going to be the one I spend the most time on because that's what's going to occur down in the soil pit. That's where the majority of your score for that section will come from. Bam. Now, why are soils important? Why do they pay Mr. Lee Jones to get up and talk about soil, or for most people, dirt? It's because soils play a critical role in just about every life process you can imagine. Food, fiber, clothing, pharmaceuticals, freshwater availability and quality, habitat, and regulation of air and climate. One way or another, everything you can think about comes back to the soils. It's truly the foundation, and without it, we wouldn't be here. Hit me. You can skip that one. A lot of these are just pretty pictures I put up to make my slides look more important if I ever have to upload them online. Let's start with our soil formation and soil properties. All right, this is important. This will be on the test. So this, I'll tell y'all what to write down specifically that I know is going to be there. This is one of them. You have your soil formation properties. I remember them through CLORT. You can remember them through CORT. Whatever makes you remember them. And that stands for climate, organisms, relief, or topography. You'll hear topography more often now, but that word relief may come up. Parent materials and time. And don't worry, I'm going to go through each one of these so you know exactly what it is and what role it plays. All right, first one we're going to talk about is climate. Both your temperature and your rainfall frequency have an effect on your soil formation. Your climate determines the rate of weathering and erosion, which determines the rate of how fast your soil is produced. Warmer temperatures and increased rainfall increase the amount of weathering, which contributes more mineral material for soil formation. Rainfall also affects leaching, pH, and soil aeration. Bam. Now, this is the carbon cycle. I would go over it, but it's not going to be on my test. Now, back to climate. This is pretty much your Spark Notes version. Every topic I go over, I'm going to have a slide at the end that gives you the key factors that you need to know. Temperature has a direct relationship with the photosynthesis process. As temperature increases, the rate of photosynthesis increases to a certain point at which either the levels begin to level off or decrease. And lower temperatures limit the number of collisions between enzymes and substrate, limiting the rate of photosynthesis. Bam. Another thing that climate affects, your type of soil. And I know these slides are probably hard to see from back there, but just know certain soils exist in certain climates. For example, aridosols. From the name itself, aridosols, where do you think those are found? Hit me, come on. The only wrong answer is the one you ain't say. Rocks. Aridosoils. Look at those first four letters for me. Nope. Let's break it down. Do y'all know what arid environments are? Bingo. Who said that? Got it. The desert. Whenever you hear arid, in this case aridosols, it involves a desert environment, somewhere hot, somewhere usually dry. Don't believe the myth that it never rains. It does, but you don't want to be there when it does. Don't worry, I won't make you know this. Next. All right. Big part of soil formation is organisms, the life forms living within your soil. play a large role in the inner workings of your soil and how nutrients are processed and how the soil itself is created. Bam. Organisms, plants, microorganisms, bacteria, etc., they all play a role in soil development. As soil forms, those plants begin to grow into the soil. Once those plants mature and die, new plants take their place and their leaves and roots are added to the soil in the form of organic matter. As far as agriculture is concerned, whenever you hear organic matter, think all you can eat buffet for plants. This is the thing that helps them thrive, helps them grow. And our plant organisms within the soil add to that soil's organic matter. And your animals and microorganisms affect the soil through a physical layer and through a texture layer as their metabolic and physical activity play on the soil. Then you have us, human beings. We affect pedogenesis, the creation of soil, by either the removal or burial of the soil profile during construction. Next. This is another one you need to know, relief topography. Topography, for those who don't know, is just the lay of the land, how it rolls, if it's a steep slope, etc. Topography influenced the soil. Excuse me, I'm tired, y'all. I ain't sleep good last night. I'm getting old. The position of the parent material in the soil affects how the soil is developed. A soil on a high hilltop won't be as well developed as a soil lying down at the bottom. That soil down there is called all of the organic material that's been washed down from that hill, which don't worry, I got pictures showing that. It pools at the bottom, and that's where you get a really rich soil. And does water move faster on a flat surface or a slope surface? Slope surface. So if you have water moving down the side of a slope as opposed to sitting still, it's carving through that. It's breaking those rocks down, getting them into smaller mineral sizes, which contribute to your soil formation. Bam. And that's just a picture telling you exactly what I was talking about. On those steep active slopes in the top left there, you'll see there's no soil. Why? All the soil has been washed down to your shallow slope area and specifically your lowland valley area in the middle, where all of that organic material, all of those minerals have pooled down to create a very rich soil. That's, as far as agriculture is concerned, that's just as good as finding oil. If you have soil that's really healthy and really productive, that's where you can get most of your value from it. Bam. And this is just another graphic showing you that process. Poor soils on the slope, good soils on the bottom. That's good. Slope classes. These are things you need to know, but it won't be like a big multiple choice thing. We'll have it set up to where you can look at your slope. And I won't do you guys dirty. I won't give you one like, is it a 2% slope or a 2.5? It'll be, is it 2? Is it 10? Is it 15 to 20? It'll be something that you would be able to tell at your eye level. And these are a few of your slope classes. And the ones I would focus on is, for our thing, is gently sloping, moderately sloping, strongly sloping. We won't run into the other ones too much. And bam. All right, parent material. This is one of the most important parts of the soil formation process. Or let me rephrase that because that's a whole nother topic. This is one of the most important soil formation factors, your parent material. Now, similar to you and I, soil does have parents. It's just their parents are rocks and our parents are at home or at work today. Now, with soil parent material, again, just like this, the soil comes out and it has the characteristics of its parent material. But as time goes on, it becomes a more mature soil, more is added to it or taken away. That's when you start to develop your different types of soil. So it does start from bedrock, just a really hard material, weathered down and broken down over time. But all of the factors in that soil, so to speak, upbringing, are what influence soils to become different things. Bam. And this is a diagram of soil. This is something I will touch on more in the presentation, because one thing you're going to have to know in the soils pit is how to distinguish your soil horizons. Luckily, at the sites we usually visit, you don't have anything super crazy. You're going to be mostly looking for color switches. Like you see at the top here, you have a really dark brown, almost black color going into a lighter brown. Then you get into a mixture of some grays, orangish, reddish. All of these things indicate different layers within the soil and different material. Bam. Now, time. Everything I've talked about today, whether it be climate, parent material, organisms, etc., without the time needed for those factors to influence the soil, they can't do anything. I can't give you a test right now without giving you time to study for it, right? If I give you a soils test now, it wouldn't be a great idea. So everything needs time to work out. You have younger soils, which are less mature. They don't have as many nutrients. They're composed differently. And your more mature soils are fully broken down. They have nutrients spread throughout them for plant life, and everybody loves them. Bam. This is just another graphic that shows the soil formation process. As that bedrock is there getting weathered, turns into organic material, that gives you some plant life coming up. And when it dies, it goes down, gives you more organic material. And over time, different layers form and you get a fully developed soil profile. Bam. All right, this is a good one. Soil horizons. If I were you, I would write down OABC bedrock and just the words right next to it. These will be important, as this will be something you will have to identify. Let's start at the very top. Your O horizon is usually not going to be too big unless you got a really good stewardship of the land and they built it over time. But you're going to find that within your first 0 to 2 inches, 100% humus is just going to be a lot of scattered organic material. Once you get past that, you get into our topsoil. That's your sediment layer. 25% of the organic matter's made it down here, but that's where a lot of the work gets done for our plants to grow and thrive. You get under that, you have your B horizon or your subsoil. It's a less matured soil. It's going to have a different texture maybe. It's going to look different. It won't have those dark colors. In most cases with soil, the darker the color, the more mature the soil and the more organic matter that's resting within the soil. Finally, you have your C horizon, which I'm not going to make y'all go to because that means I would have to dig a 50-inch hole and I don't feel like doing it. The C horizon is just going to be weathered bedrock surface. It's going to have unsorted texture and it won't have any organic material. And then you have bedrock. That's the parent. We're not going to get down that deep. Let them finish riding. I'm trying to get through this so I can get to the fun part. All right, bam. This is just another graphic or a zoomed in graphic so you can see how the different horizons have different colors that can be distinguished throughout the soil profile. Like everybody can see, this goes from a black, brown, orangish to a real grayish, muddyish color. Bam. All right, you can skip that. That just goes back to time. All right, this is the part that's going to matter more than everything else. Everything else is theoretical, history, background knowledge. This is what's going to comprise the majority of the soil pit. Your soil physical properties. We're going to talk about particle size. Don't worry, that one's not going to be on the test. I just threw that in there because I got different particles here. Texture, that's going to be the biggest one on the test, texture. So we're going to go through that a little more thoroughly. Color, and finally, your structure. Let them get their picture real quick. All right, bam. All right, with soil particle size, just about the only thing y'all will need to know, grab this out of here, is as in terms to individual particle size, sand is the largest, silt is in the middle, and clay is the smallest. Which, when you have sand particles, if you look on this leftmost diagram, high permeability, there are big spaces in between. Water can flow through pretty freely. Whereas when you have clay with the small particle size, everything's bunched up into a small group. Water won't be able to penetrate nearly as easily. All right. And this is just a diagram showing you how soil particles will naturally separate if you put them in a jar, add a little bit of water, leave a little space for air and shake it up. Those soil particles will sort themselves out into layers according to their texture. Next. This is just a realistic version of that. Hit it. All right. Now this is what I gave you. And while it may or may not be on the test for you to read one of these, it's more than likely going to be there since I took time to print 40 of these this morning. This is your soil texture triangle. And I printed this specific version because there is a key difference between the one you're holding and the one up there. This one has the numbers slanted to show you which way to read them, whereas that one just has 3 straight lines. And I will go over how to read this, but before that, let's talk about soil texture and what to look for. And let's start with sand. I start with sand because it's the easiest. Everybody here been to the beach or a playground at least once? Bingo. You know what sand feels like. It's really gritty. If you look at it in the sunlight, it'll sparkle back at you. If you hold it up to your ear, you'll hear the grit as you rub it between your fingers. So sand, real gritty. Silt. Silt, when it's in its natural state in the wild, you dig it out of a hole, it feels like milled flour when you press it against. It's going to give you a real smooth feeling. If you've ever baked with grandma, auntie, mom, you know how flour feels. Then you got clay. Clay is another easy one. If you'll just look at the table up here, you'll see everything is laid out in nice grains, and then you got clay. When it's wet, it will stain your hands, and you'll be able to push it between your thumb and your index finger and make a ribbon up to 1 inch, maybe 2 inches, that holds its shape. So clay stains your hand, heavy when it's wet, can make a ribbon or a ball. And now, the triangle itself. So, if you all will look on the left-hand side of the page and look at clay, what direction are those numbers oriented? Are they curved? Are they straight? Straight. So for the clay section, you take that number, you go straight across. For the bottom here, it's your silt. Are they at an angle or are they straight? Go through the angle. Same thing with your sand at the bottom. So, walk with me here. If I tell you I have a soil that's 50% clay, so just go and put your hand on the 50. And remember, everything we do with soils has to add up to 100. So if I tell you a soil is 50% clay, 50% sand, where do you end up? All right, now, walk with me. It's 50% sand, 50% clay. Bingo, sandy clay. That's the whole chart, y'all. It's that easy to read. I'm never going to give you a trick question. It's always going to add up to 100, and it'll be as simple as following the lines with your fingers. Next. All right. And this is just a document saying everything I just told y'all. Sand, gritty, does not stain fingers, does not form ribbon when wet or moist. Loamy sand, don't worry, I'm not going to do y'all like that. It's not going to have sand, loamy sand, or sandy loam on the test. I don't think that's fair to y'all. It's going to be different soil textures that you'll be able to differentiate. So then you got loam at the bottom, because we're skipping the sandies. We're not going to do that. It's going to feel like sand. You'll know it. Loam will have a slightly gritty feel, but does not show a fingerprint, and it will only form a short ribbon. And I realize now I've said the word loam. Do y'all know what loam is? I didn't expect you to. Loam is just a mixture of sand, silt, and clay. So if you hear loam, you got a mixture of all 3. Sandy loam, you have a mixture of all 3 predominated by sand. Clay loam, etc., etc. Bam. And this just goes back into the other textures for silt. Flowery feel when moist. Sticky when wet, but will not ribbon. And it will form a ball that will hold some handling, but if you put weight on it, it'll disintegrate. Then we go down to our bottom. We have our clay loam. It's sticky when moist. It forms a thin ribbon from 1 to 2 inches in length, and it produces a slight sheen when rubbed with the thumbnail. Bam. And this just goes into your various different clays. Your sandy clay is going to feel like a clay, but it'll sparkle back at you if you hold it in the sunlight, and you'll be able to feel that grit against your fingertips. Bam. Color. This is the second most important part of the soils pit. And this one will be more so a gimme, if I'm honest, because I'm going to give you the book, and I'm going to ask you to identify the soil color, and this is the book. It is a Munsell color book, and they are way more expensive than I thought they were. Some of these books are 1,000 plus, but it's because this book that I got a few years ago still looks like this book that was made before I was born. And you all will get a chance to play with these books, to go throughout them, and I'll explain in detail the coloring process when we get to the hands-on portion. Bam. All right. This is important. This is one I would write. What factors determine soil color? Organic matter content. Remember, I told you the darker it is, the more organic matter you're going to have in it 9 times out of 10. Your mineral content. The minerals that comprise the soil make up its color. Big one, the iron content. That's going to be on a lot of your clay-rich soils. It's going to give you that burnt orange, reddish color. And your moisture content. Number 1 rule for soil color determination, never do it dry. A soil that's dry is not going to be the same color as a soil that's moist. So just remember that when we get to that portion of the soils pit, when I see y'all again, don't do it dry. Get a little bit of water if the soil is dry, and then try to color it. 1 second. All right, bam. Now, what you have on screen are just different colors that soil can be. Usually when we say soil, you probably think brown, dirt-like color, but soil has a wide variety of colors. Whites, grays, reds, some look almost bluish. Bam. This is just a diagram of the Munsell color book, but luckily I have 3 on hand, and we'll get to go through those personally. Bam. And here are some indicators for your color. Don't worry, this part will not be as important for the test itself, just general knowledge for you. Light brown soils, low in organic matter. Dark brown, high in organic matter. Black, you pretty much struck oil as far as soil is concerned. When you have a reddish soil, it's weathered or nutrient poor. Red and brown soil, good drainage, water's flowing through. Yellow, moderate drainage. Gray, poor drainage. That just means there's water being held within that soil. So if you look in a soil profile and you see streaks of gray or areas of heavy gray color, that is a soil that is holding water for a substantial amount of time. And that water is interacting with the iron, giving you a gray color. Then you have white, light grays. It's going to be something sandy. Bam. You can skip that one. Yep. And structure. This one won't be as important, but it could pop up on the written test that I don't make. Your soil structure is broken up into several sections, including granular, blocky, platy, massive, single grain. I won't include this on you because even the soil scientists sometimes we get this wrong. But these are just things to know the different ways that soil can form. It's not always going to be loose, fine dirt. Sometimes you're going to get long structures, prisms, or plates. In just a second. All right, bam. And these are just different diagrams showing you how those soils can lay out. Bam. All right. Now, the reason I bring up structure is because this is something that may come up. Soil structure influences how air and water move throughout the soil. When you have a granular soil, you have a lot of spaces in between for water and air to flow through. When you have a prismatic soil, kind of like that clay I picked up where it's just big prisms, the water can only flow in the spaces that the prisms do not exist. Then you have subangular blocky, that's big soils, mumbo jumbo, nobody else will get excited about that. And platy soil, it just forms different layers, legitimate plates, and the water has to go in between them. Bam. This is important. It will be on the written test and my field test. Your ideal soil composition. 45% minerals, 25% air, 25% water, and 5% organic matter. I can almost guarantee you that that's going to be on both versions of the test. 45% minerals, 25% air, 25% water, 5% organic matter. It will not always be like that, but this is the ideal soil composition if you get asked that question, or when you get asked that question. And if you can remember 45, 25, 25, the other 5 you can just think as dead leaves and animals. I think we're almost there, Russell. You know, I live for the hands-on stuff. All righty. Bam. And this is just a diagram showing you the differences between an ideal soil and what we call a compacted soil, where that soil has been mashed together and the space in between the granules has been taken away. When you have an ideal soil, you're 50% solids, 25% water, 25% air. Water and air can move freely throughout that soil, and it'll give more access to nutrients and et cetera for the plants that thrive there. Whereas when you have a compacted soil, nothing can get through it. If you think, for all of my football folks, that means you got a good O-line or D-line, specifically a good O-line. Nothing can pierce through because everything is a tight-knit bond. And soil is bad. Bam.